Have you ever looked up at the night sky and wondered where all those twinkling stars come from? It's a question that has puzzled humans since time immemorial, sparking a curiosity that has led us to the frontiers of human knowledge. Stars. These celestial bodies are not just beautiful, they are crucial. They are the building blocks of the universe, the very fabric that weaves together the cosmos. Their existence, their formation, their life and their death all play a pivotal role in the grand scheme of things. Stars are born, they live, and they die, just like us. But their life cycle is a process so intricate and fascinating, it's nothing short of a cosmic ballet. From the birth in nebulous cradles to their luminous existence and eventual demise, the life of a star is a journey that's as awe-inspiring as it is complex. Join us as we delve into the fascinating process of star formation. Our journey begins in the vast cold cosmos, in a place known as a nebula. A nebula, from the Latin word for cloud, is indeed ethereal and otherworldly, an immense cloud in outer space, composed of dust, hydrogen, helium, and other ionized gases. It's a sight to behold, a splash of colors against the stark black canvas of the universe, stretching millions of miles across. There are different types of nebulae, each playing its own unique role in the cosmic theater. Some are birthplaces of stars, while others are the remnants of stars that have ended their stellar journey. Let's delve into this a little more. First, there are emission nebulae, often referred to as hot eye regions. These nebulae are large, diffuse clouds of ionized gas, glowing brightly as they are heated by the ultraviolet light from nearby hot stars. The most famous example of an emission nebula is the Orion Nebula. Then we have reflection nebulae. They are not luminous by themselves, but they shine by reflecting and scattering the light from nearby stars. These nebulae often appear blue because blue light is scattered more than other colors. Dark nebulae, as the name suggests, are dark and opaque to visible light. They appear as dark patches against the background of brighter stars or nebulae because of the dust particles present in them that block light. Lastly, we have supernova remnants, the remains of massive stars that have ended their lives in supernova explosions. These nebulae are often the source of beautiful and intricate structures we see in images from space telescopes. Nebulae are not just beautiful to observe, they are crucial in the process of star formation. Stars are born within the confines of these cosmic clouds. The dust and gases that make up nebulae, primarily hydrogen and helium, clump together under the force of gravity to form what we call a protostar, the earliest stage in the life of a star. It is within these cosmic nurseries that stars begin their life. From the densest parts of the nebula, a star begins to take form. Now let's delve deeper into the exciting process of how a star, or more accurately, a protostar, comes into existence. Picture this: you're in the heart of a nebula, surrounded by dense clouds of gas and dust. These are the star-forming regions of the universe. The process begins when gravity, that unyielding cosmic force, starts pulling together these nebular materials. It's as though the universe itself is kneading dough for the bakery of the cosmos, creating a dense core within the nebula. As the nebular material starts to accumulate, a process similar to a cosmic snowball effect, the core's gravity becomes stronger. It continues to pull in more and more material, growing denser and denser. But here's the catch. All this compression generates a lot of pressure. And what happens when you pressurize something? It heats up. This is where things start to get interesting. As the core heats up, it becomes a glowing ball of gas. This is not a star yet, but it's the next best thing, a protostar. Imagine it as a baby star, not fully formed but well on its way. The protostar is still gathering mass from the nebula, but it's already begun to glow due to the heat generated by gravitational compression. But the protostar's journey isn't over yet. It continues to grow, pulling in more material and increasing its temperature. The protostar is on a path that will eventually lead it to become a fully fledged star. It's a process that takes hundreds of thousands to millions of years, showing us that stars, like fine wine, take time to form. In the grand cosmic ballet, The formation of a protostar is a pivotal moment. It marks the transition from a simple cloud of gas and dust to a glowing beacon in the sky. It's a testament to the power of gravity and the intricate beauty of the universe. This is the first major step in the journey of a star's life. And what a journey it is, filled with cosmic wonder and celestial marvels. But how does a protostar become a star as we know it? That's a great question, and the answer lies in the process of growth and maturation that every star undergoes. It all starts with a protostar, a baby star if you will, nestled within a dense cocoon of gas and dust. This protostar is not content with its current state and yearns to grow. And so, it does what any ambitious celestial body would do. It begins to gather more and more material from its surroundings. It draws in gas and dust from the nebula it resides in, increasing its mass and size. This process is called accretion. As the protostar continues to accrete material, something marvelous begins to happen in its core. The core of the protostar grows hotter and denser under the weight of the additional material. We're talking about temperatures rising into the millions of degrees, hotter than you can possibly fathom. Now, here's where things get really interesting. As the core temperature rises, the conditions become just right for the process of nuclear fusion to begin. This is the process where hydrogen atoms in the core start to combine to form helium. This nuclear fusion releases a tremendous amount of energy in the form of light and heat, but we're not quite there yet. The energy produced from nuclear fusion creates an outward pressure that balances the inward pull of gravity. When these two forces reach equilibrium, the protostar stops accreting material and the core stabilizes. This marks the birth of a main sequence star, a star as we know it. So, from a humble protostar, through a process of accretion and the onset of nuclear fusion, we witness the birth of a star. This newborn star will continue to shine for millions to billions of years, a beacon of light in the vast cosmic ocean. And voila, we now have a star. A celestial wonder, born from dust and gas, now shining brightly in the cosmos. Isn't that just astonishing? A star's life doesn't end at its formation. Quite the contrary. This is where the true spectacle begins. Stars, much like us, undergo various stages of life, each with its unique characteristics. In the prime of their lives, stars enter a phase called the main sequence. This is the longest stage, where stars spend about 90% of their lives. Here, they steadily burn hydrogen into helium in a process known as nuclear fusion. This fusion generates immense energy, causing the star to shine brightly, illuminating the cosmos. As billions of years pass, stars eventually exhaust their hydrogen supply. This marks the beginning of the end. They morph into red giants or supergiants, then shed their outer layers to form planetary nebulae. The cores that remain become white dwarfs, neutron stars, or even black holes, depending on their initial mass. Throughout their life, stars continue to play a pivotal role in the cosmos. Their journey, from birth to death, is a captivating dance of cosmic evolution. So, we've journeyed from nebulae to the birth of a star. Our cosmic voyage began in the dense, rich clouds of nebulae, filled with dust and gas. The gravitational forces within these nebulae set the stage for the birth of a star, pulling particles together to create a hot, dense core. We then followed the evolution of this core into a protostar. As gravity continued to pull in more matter, the protostar grew hotter and denser, its internal pressure increasing until it ignited nuclear fusion, the process that fuels a star. From there, the protostar matured into a main sequence star, a fully formed celestial body that shines brightly in the sky for millions or even billions of years. Thus, we've seen how a star, that brilliant point of light we marvel at in the night sky, is born from humble beginnings in a nebula. The next time you gaze at the stars, remember the incredible journey they've taken to shine brightly in our night sky.